Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 12 video from the chapter of coordinate geometry where I will discuss about how to find the area of a triangle whose 3 points are given. That is, the coordinates of 3 points are given and we have to find the area of the triangle joining those 3 points. This video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so we are given three coordinates of 3 points A, B, and C. Coordinates of the point A are x1, y1. Coordinates of the point B are x2, y2, and coordinates of the point C are x3, y3. The triangle, you have to find the area of the triangle joining these 3 points. Now, it is quite possible that if you join the triangle formed by joining these 3 points will be very special, or it will be very easy to compute the area. So I will discuss them case by case. Case one is where if you in the triangle you will see that one side is parallel to the y-axis. So I will not draw the x-axis and y-axis. Hope you will understand. I'm just drawing the triangle. So let's say the side. Let's say the side. Okay. Let's say the side. So one side is parallel to y-axis. Now it could be, that side could be along the positive direction of the x or along the negative direction of the x. It does not matter. So let's say this is the side which is parallel to the y-axis, and let's say this be the vertex B and this be the vertex C. So the coordinates of the B point vertex B is x2, y2, and the coordinates of the point C is given as x3, y3, and the other vertex A could be anywhere. It could be to the left hand side of BC, the side BC, or it could be to the right hand side of the BC. It does not matter. I am considering, let's say, the other vertex is A. So this is the vertex A whose coordinates are x1, y1. So the triangle is ABC. So this is the triangle. Remember that the side BC is parallel to the y-axis. Okay. So now I have, in case 1, I am considering BC, the line segment BC is parallel to the y-axis. So this will imply if the line segment BC is parallel to y-axis, then obviously the abscissa of the points B and C, they will be equal. So x2 will be equal to x3. Okay. Then I can find the length of the side BC. A line segment which is parallel to the line segment joining the points B and C, where the line segment is parallel to the y-axis, its length will be BC will be equal to the difference of the absolute value of the difference of the ordinates of the point B and C. So y2 minus y3 will be the length of the side BC, absolute value of y2 minus y3. Okay. Now to find the area. Okay, now to find the area of the triangle, I will apply the formula half into base into height, where I will consider the side BC as the base which is parallel to the y-axis. So I have to draw a perpendicular from the opposite vertex A on BC. Let's say if AE is perpendicular to the side BC, then what will be the length of AE? Remember that BC is parallel to y-axis and AE is parallel to AE is perpendicular. AE is drawn perpendicular to BC. This will imply that AE is obviously parallel to the x-axis. Since BC is parallel to the y-axis and x-axis and y-axis are perpendicular to each other, and if AE is perpendicular to BC, obviously AE will be parallel to x-axis. So this will imply I can easily find the length of the perpendicular AE. So AE will be equal to, if a line segment is parallel to x-axis, and if I know the endpoints A and E, then I can find the length of AE. It will be the absolute value of the difference of the abscissa of the points A and E. Okay. Now what will be the abscissa of E? Abscissa of the point E is lying on the line segment BC. So the abscissa of E will be same as the points B and C. So it will be, I am considering so x2 minus x1. Absolute value of x2 minus x1 will be the length of the AE, which is perpendicular to the side BC. So now I can clearly, area of the triangle ABC will be equal to half into base, that is BC, multiplied by the perpendicular on the side BC from the opposite vertex, which is AE. So this will be equal to half multiplied by BC. BC is y2 minus y3, absolute value of y2 minus y3, multiplied by AE is absolute value of x2 minus x1. Now never and ever try to please try to understand the concept, what concept I am applying. So this is not a formula that I am explaining or giving to find the area of a triangle where the coordinates of the vertices A, B and C are given and BC is parallel to y-axis. Then this will be the formula. No, apply understand the concepts and apply it to find the area. Any other side instead of BC, it could be AC is parallel to y-axis, or it could also be AB is parallel to y-axis. So just understand the concept. Okay, so this was this way we can find the area of the triangle if we see that one side is parallel to the y-axis. Now in the case 2 is the case where one side will be parallel to the x-axis. So let's say this side, this time this is the side parallel to this is the side of the triangle formed parallel to the x-axis. So let's say this time I am considering the vertices to be A and B, where the side AB is parallel to x-axis. So we have the point A1 is x1, comma y1, the point B is x2, comma y2, and the points other vertex C could be anywhere. It could be above the side AB, or it could be below the side AB. I am considering above the side AB. That is, above means towards the positive direction of the no, not towards the positive direction of the x. The whole triangle could be completely in any of the quadrants, or it could even overlap with 2 or more quadrants. Let's say this is the point C, or even let's say this be the point C, the other vertex, which is x3 comma y3. Okay, so this is the triangle formed ABC. So we have considered the side AB to be parallel to the x-axis. X1, the side AB is parallel to the x-axis. So clearly we are assuming that AB is parallel to x-axis. So this will imply clearly that the ordinate of the points A and B, they will be same. 2 points lying on a line parallel to x-axis, they have the same ordinate. So this implies we will have y1 is equal to y2. So this is the observation. How will you know that one side of the triangle form is parallel to x-axis or y-axis? So these are the conditions. If you see 2 points are having the same abscissa, then it will mean that the side joining those 2 points is parallel to y-axis. And if you see in the given 3 points ABC, the 2 points are having same ordinates, then the line segment joining those 2 points will be the side which will be parallel to the x-axis. Okay, so now I can, from this fact, I can clearly find the length of the side AB. AB will be equal to the absolute value of the difference of the abscissa of the points A and B. So x1 minus x2, absolute value of x1 minus x2. Now I need to find the length of the perpendicular from the vertex C on the side AB. So let's say CE, this is CE is perpendicular, CE is drawn perpendicular to AB. Now obviously the ordinate, since the point AEB lie on the same line, so lie on the same side or line segment AB, clearly they will have, and the line segment AB is parallel to x-axis, clearly the points AEB will have the same ordinate. Okay, so the ordinate of E will be y2. Now in the previous case, the ordinate of the point E was x2, and we don't know, this could be anything, we don't know, it will be something, a value, ordinate will be some value in between y2 and y3, we don't know which, and it is not important to know the ordinate of the point E in the case 1. So in the case 2, we know that the ordinate, we are not interested in the abscissa of the point E, we don't need it, but we need the ordinate of the point E, which is y2. That is not, I mean, y2 means we know that y1 is equal to y2. So the ordinate of the point E will also be the same as the ordinate of the point A and B. Okay. So we know AB, length of AB, that is the base. And so what will be AE? What will be the length of the perpendicular EC or CE? Now the line CE will be parallel to y-axis, because the line CE is perpendicular to AB and AB is parallel to x-axis. So clearly CE will be parallel to y-axis. So then the length of the CE will be the difference, the absolute value of the difference of the ordinates of the points E and C. So it will be absolute value of y2 minus y3. So now we can say that the area of the triangle ABC, will be equal to half into AB into CE, which is equal to half multiplied by AB was absolute value of x1 minus x2, and CE was absolute value of y2 minus y3. So this way we can find the area of the triangle form if we see one side is parallel to the x-axis, and we will determine how we will know that one side is parallel to x-axis. We will see that 2 points of the given 3 points are having the same ordinate. Okay, case 3 is that the triangle formed will be right angle triangle, that is one side will be parallel to x-axis and another side will be parallel to y-axis. So let's say this is the side parallel to the y-axis. Let's say this be the side AB. Coordinates of A is x1 comma y1, coordinates of B is x2 comma y2, and let's say the side AB and BC are perpendicular to each other. Now when we will understand that we will see that one side is parallel to the x-axis and another side is parallel to y-axis, then the triangle formed has to be a right angle triangle. So I am considering the side BC, where the coordinate of the point C is x3, comma y3. So BC is parallel, the side BC is parallel to x-axis and the side AB is parallel to y-axis. So the triangle ABC is now a right angle triangle. Now clearly in this case, okay, now AB is parallel to y-axis, which we can say, or which we will know or observe when we will see that for the points A and B, their abscissa are same. That is, x1 is equal to x2. Then the line segment AB will be the side AB will be parallel to y-axis. And also we are assuming that, not assuming, based if BC has to be parallel to x-axis, then obviously the points are given such that if BC, the line side BC is parallel to x-axis, which means that the ordinates will be same. That is, y2 is equal to y3. So if we see for 2 points, this is if from the given 3 points, from the given coordinates of the 3 points, if we see that 2 points are having the same abscissa and another 2 points are having the same ordinate, then the triangle formed will be a right angle triangle. So now, okay, so what will be the area of the triangle? Will be half into AB into BC. So what will be AB? AB, since the line segment AB is parallel to y-axis, its length will be the absolute difference of the ordinates of the point A and B. So y1, absolute value of y1 minus y2. And since the side BC is parallel to the x-axis, its length will be the absolute value of the difference of the abscissa of points B and C, x2 minus x3, absolute value of x2 minus x3. So then the area of the triangle ABC will be equal to half into AB into BC, which will be half multiplied by absolute value of y1 minus y2 multiplied by absolute value of x2 minus x3. So this was the case when we see joining the 3 points, the triangle form is right angle triangle, because we see that one side is parallel to x-axis and another side is parallel to the y-axis. Okay, now the final case will be the most complicated. I mean, you have to apply the Heron's formula, because the triangle formed by the joining the 3 points, they are neither right angle triangle or none of the sides is parallel to any of the coordinate axes. So I have to find the distance of all the 3 points using the distance formula, that is the distance between 2 points. So let's say this is the triangle, this is the let's say this is the triangle form. This is the vertex A, x1 comma x2, sorry, x1 comma y1. The point B is x2 comma y2. If the triangle formed in is false in any of the first 3 cases, then it will be basically easy to compute the find the area of the triangle. And the vertex C is x3 comma y3. So I have no other choice. I have to individually find the length of each of the sides using the distance formula, that is the distance between 2 points. And then once I know the sides, length of each sides, I will apply Heron's formula to find the area. So what will be AB? AB, using the distance formula, that is the distance between the points A and B, the length of the side AB is equal to the distance between the points A and B, which is equal to square root of the difference of the abscissa plus square of the difference of the ordinates. This is AB. Similarly, AC will be equal to the distance between the points A and C. Square root of square of the difference of the abscissa of the points A and C, x1 minus x3 square plus y1 minus y3 square, and BC finally will be equal to square root of x2 minus x3 square plus y2 minus y3 square. Most probably it is rarely you will be given a problem to find the area of a triangle whose vertices are given, coordinates of the vertices are given, and you have to, and it is neither a right angle triangle nor any of its side is parallel to the x-axis or y-axis. The case 4 will be problems given will rarely fall in the case 4. Okay, so I know I have found the length of the sides using the distance formula, and then so you know that the length, so AB, AB is the side opposite to the vertex C. So the length of the side AB is denoted with the small letter C. This is the conventional. This is the convention. So the length of the side. So this is C. The length of the side AB. The length of the side AC AC will be denoted by, since the side AC is opposite to the vertex B, its length will, the length of the side AC will be denoted conventionally with the small letter B, and the length of the side BC is denoted by the small letter A, as it is opposite to the vertex A. Okay, so AB is equal to so C. So this, so C, small c is equal to AB, AC is equal to small b, and A is equal to BC. Okay, so now we know the Heron's formula. Heron's formula, we have to find the semi perimeter of the triangle ABC, which is small s. Small s will be semi perimeter. Semi perimeter means A plus B plus C by 2. This is the semi perimeter of the triangle ABC, where AB and C, small letter AB and C, are the length of the sides. Okay, so now I have found the semi perimeter, which is denoted with the small letter S. I know the area. Heron's formula, using Heron's formula, the area of the triangle ABC will then be equal to square root of small s into S minus A multiplied by S minus B multiplied by S minus C. So you know S, you know A, B and C. In this way you can find the area of the triangle ABC using this Heron's formula. Most probably the problems given to you will fall in the cases in case 1 or 2 or 3. So that is all for this video. I am not solving any problem. Probably I will make a video. I will make 2 videos where I will solve problems based on all the concepts that I am discussing for the last few videos, and there are more concepts to discuss. So if this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.